Hello and good day, Geometry, here with you for an emotional lesson because it is our last lesson dealing with right triangles. PO43, the last lesson of Unit 7, this talks about the inverse of sine, cosine, and tangent. In PO42, we learned what those buttons on your calculator mean, sine, cos, and tan. And we learned that knowing an angle of the triangle, other than the right angle, and knowing one side, you can use these ratios to solve for the other parts. Well, the same is true if you know two of the sides and you're wondering what the measures of the angles are. And in this case, we are using the inverse of sine, which on your calculator is sine to the negative first power. It kind of looks like that. The inverse of cosine, which is cosine to the negative first power, and the inverse of tangent, which is tangent to the negative first power. And really, it's referred to the inverse of sine, the inverse of cosine, the inverse of tangent. It looks like it's to the negative one, but it's a little bit different than that. But anyway, again, I'm going to remind you, please make sure that your calculator is in degree mode. Radian or anything else is not going to work for you, so make sure it's in degree mode. And here's how it's used. Our task for each of these three triangles here is to calculate the measure of angle A. So here's angle A, okay? And the reason why we'll be using the inverse of sine to solve for angle A is because from that angle, again, we're kind of going to the locations here, from that angle, the two known sides are the opposite side, 5, and the hypotenuse, 11. That's how we know that we're using sine. To find angle A, we look at the location of the sides that we know. In this case, 5 is opposite and 11 is hypotenuse. And sine being opposite over hypotenuse, that's the one that we're going to be using. So how we set this up, inverse of sine, opposite over hypotenuse. Sine to the negative first, inverse of sine. It should be right above your sine button on your calculator. So you'll need to, again, make sure it's in degree mode there. And then probably press the second function button. And so sine negative 1 will appear along with a parenthesis. And then 5 over 11. And we get rounded to nearest hundredth, 27.04. Actually, we'll round the nearest angle here, approximately 27 degrees. Okay. And so if you were also asked, my green marker is kind of off today. If you're also asked to find the measure of angle C, well, if we know that angle A is about 27, we know that angle C is complementary with angle A. That's going to be a measure of approximately 63 here. Okay. And we can check that by taking the inverse of cosine for angle C, because if we're looking at angle C, 5 is now the adjacent side, 11 is the hypotenuse. And if we do the inverse of cosine adjacent over hypotenuse, 5 over 11 in our calculator, we get 62.96, which is approximately 63. Okay? I'm going to switch markers here so I can write a little bit more accurately. For the next one, we're looking for angle A, which is now down here. And so from angle A, the reason why this is going to be cosine is because 7 is adjacent to it, 12 is the hypotenuse. And the ratio that includes the adjacent side and the hypotenuse is cosine. So in your calculator, inverse of cosine, adjacent 7 over hypotenuse 12. And that gives us about 54 degrees for angle A. If you're not getting 54, check to make sure that you're using the inverse of cosine and not just cosine. Make sure that you have your fraction in the correct order, adjacent over hypotenuse, 7 over 12. And then check to make sure that your calculator is in degree mode. Okay? If you're not getting 54, it's very much likely one of those three issues. And lastly, to find angle A here with the inverse of tangent, there's angle A. The sides that we know, 10 and 22, from angle A, 10 is opposite angle A. 22 is the adjacent side to angle A. We don't have the hypotenuse here, right? The hypotenuse is across from our 90-degree angle. That's the side that we don't have. this one here. So we're not using it. And so we'll be using inverse of tangent. So in your calculator, inverse tangent, opposites, 10 divided by adjacent, 22. That's the tangent ratio, opposite over adjacent. And that should give you about 24 degrees. 24 degrees, which means that angle C, if you're asked to find that, is going to be 66 degrees. Okay, so that's kind of the gist of it. Very similar to sine and cosine tangent. We're still using those SOHCAHTOA ratios. We're still using locations of sides to determine which ratio we are going to use. It's just now we're using the inverse so we can calculate angle measures rather than sides. And armed with all of this, everything that we've done in this unit, the Pythagorean theorem, special right triangles, sine, cosine, tangent, the inverse of sine, cosine, tangent, we are now able to solve right triangles. And when it says solve a right triangle, what we mean is find all 6 parts, all 3 angles, and all 3 sides. Okay, and really one of the angles is already done for us, right? That right angle. So to solve this right triangle, we are looking for side DE, we are looking for side DF, and we are looking for side EF. We are looking for angle D, we are looking for angle E, and we are looking for angle F. To solve a right triangle, we want all 6 parts. Let's fill in what we know. We know that angle E is 90. That's our right angle. That's marked. It's given to us. We know that side DE is 10. And we know that side DF is 17. Okay? So looking at what we have left to find, which is one side and then 2 angles, we can kind of pick and choose what methods we're going to use here. If I'm looking at this and I see that we have 2 of our sides and we're looking for the third, I'm going to use the Pythagorean theorem, because the Pythagorean theorem is designed for when you do have 2 of the sides and are looking for the third. So to find side EF, which is our B side, it's one of our legs, we can set up the equation a squared plus b squared equals c squared, or 10 squared plus b squared equals 17 squared. I know that 17 is my hypotenuse because it's opposite the right angle. So we have 100 plus b squared equals 189. 289. Oh boy, that's embarrassing. Sorry. 289. Kind of jumped ahead a little bit. So that when we solve for b, subtract 100 from both sides, there's our 189. And the root of b, remember to undo that exponent, we're going to root both sides here. I'll draw that in red so you can see it. Root both sides, cancel those operations out. B is going to be the square root of 189. And on a test, that's all we would need to see. Okay? If you want to try and go from extra credit, you could try and simplify it. Which, to simplify a square root, what we're doing is we're looking for a factor of the number that is a perfect square. So running through the factors of 189, we know that 9 is a perfect square. Root 189 is root 9 times root 21, because 9 times 21 equals 189. We care about that perfect square because we can reduce that to be 3. Root of 9 is 3. Root 21, we can't simplify any further. It does not have any perfect square factors, so we leave it as 3 root 21. So on a test, this is an acceptable answer. This would get you extra credit. Okay? To solve for angles D or F now, we can decide which one we want to go with. We'll be using the inverse of sine, the inverse of cosine, the inverse of tangent. It just depends on which ratio we're going to use, and that's determined by which angle we're going to try and find. So why don't we go for angle F here? Okay, I'm in a sine kind of mood. From angle F, side 10 is the opposite side, and 17 is the hypotenuse. And because we're using the opposite side and the hypotenuse, we're going to be using the sine ratio. If we had gone for angle D, then we'd be using cosine, which is adjacent 10. Now 10 is adjacent to angle D, and hypotenuse 17. So going for angle F, though, it's the inverse of sine. The opposite side is 10. The hypotenuse is 17. And so the inverse of sine, 10 divided by 17 in a calculator, gets us approximately 36 degrees. So angle F is about 36 degrees. We solve this to be root 189, or 3 root 21. And then angle D, if F is 36, we can just subtract 36 from 90, and that gives us 54. Okay? So, solving a right triangle, finding all 6 parts using all the methods that we've talked about thus far. Next one. What are the 6 pieces that we need to solve for here? We're looking for side GH, side HJ, and side GJ. And for our angles, we have angle G, we have angle H, and we have angle J. And in this case, different from our first triangle, one side is given to us. Side HJ is 13. And angle H, our right angle, 90. And angle J is 28.9. And since we have 2 of our angles, finding the third one just involves subtraction. 90 minus 28.9 gives us 61.1, right? We know that G and J have to add to be 90 to combine with our right angle to make a total of 180. So given that angle J, we can subtract that from 90 to get 61.6. And now we're left with GH and GJ. And we're kind of locked into sine, cosine, tangent here because we only know one side. So we need to use sine, cosine, tangent to find a second one. But we can pick which side we want to find. And let's look for, let's go for GH. Okay, let's look for side GH here. Okay. So what we're going to set up is from the angle that we're using, which is 28.9, GH is the opposite side. HJ, the one we know, is the adjacent side. So we'll be using tangent, opposite over adjacent. So the tangent of our angle, and we're not using the inverse here because we know what the angle is. We're looking for the side. So tangent of 28.9 over 1 equals the opposite, GH, what we're trying to find, over adjacent, the one that we know. So now we're going to find the tangent of 28.9, which is about 0.55. So 0.55 over 1 equals x over 13. Using cross products, 0.55 times 13 equals x times 1, or just x. So the x already by itself, we just have to multiply 0.55 by 13, and that's going to give us 7.15, which is the value for GH. Okay, and now we've got some options here, don't we? We could use sine, cosine, tangent a second time to find GJ, or since we have 2 sides of our right triangle, we can now jump to the Pythagorean Theorem. In the spirit of kind of sticking with the theme of 42 and 43, let's again use sine, cosine, tangent. Okay. So, and actually, to be quite honest with you, using sine, cosine, tangent is going to be more accurate than the Pythagorean Theorem because that 7.15 is a rounded answer. It's rounded because we rounded the 0.55, the tangent of 28.9. So if we use 7.15 in the Pythagorean Theorem, because it's a rounded answer, our result, the hypotenuse, is going to be less accurate than if we use sine, cosine, tangent and did not use a rounded answer. So in this case, looking for now GJ, still using that angle 28.9, From that angle, we now have the adjacent side, which is 13, and we're looking for the hypotenuse. Thus, our ratio is going to be cosine. The cosine of 28.9 over 1 is equal to the adjacent side, which is 13, over the hypotenuse, which is now what we're trying to find, so it's x. And because we're not using that rounded value, this will actually get us a more accurate answer for the hypotenuse than the Pythagorean theorem would have. So cosine of 28.9 is 0.88 when we round. So 0.88 over 1 equals 13 over x. Because x is in our denominator, we're going to have a little bit extra work. Here's one extra step. 0.88x equals 1 times 13, which is 13. So dividing both sides by 0.88 to get x by itself. 13 divided by 0.88 is 14.77. Okay? 14.77. Let's put those values in here. 14.77 for that, 7.15 here for that. And we can kind of look at this and do our answers make sense? I mean, our hypotenuse, that 14.77, is the longest side, which it should be, being the hypotenuse. And we can use the Pythagorean theorem here just to quickly check. I'm going to take 7.15 and square it. Add to that 13 squared, and I get 220.1225. I'll round it down to 220. Then I'm going to take 14.77, square that, and I get 218.1529, just round down to 218. Now, 220 is not equal to 218, right? Which, using the Pythagorean theorem, a squared plus b squared is supposed to equal c squared. In this case, it doesn't. But again, this is a perfect illustration of understanding that using rounded values, which both of those are, affects the accuracy of an answer. If you don't understand that, you might look at the 220 and the 218 and think, oh boy, I did something wrong, right? They're supposed to be equal, but they're not, okay? But understanding why they're not perfectly equal, they're close enough, and that's because of those rounded answers. So just be careful of that, okay? Your assignment for solving right triangles for 7.3 is going to be, sorry, a good teacher would have had this prepared for you already. Let's look at page 486, and I would like you to do 10 through 15. Page 486, 10 through 15. It's a nice variety of, sometimes you are given one side and one angle, other times you are given two sides, but you're looking for all 6 parts of these right triangles, all 3 sides, all 3 angles, okay? You'll notice, using sine, cosine, tangent, our answers are in decimal form. When we did use Pythagorean theorem, it was left in root form, so just be wary of that too. Okay, leave Pythagorean theorem answers in root form, sine, cosine, tangent, and decimal form is fine. All right, folks, that wraps up Unit 7. This lesson is posted on Friday, so come next week, Monday or Wednesday, for the practice test. We'll do it together in class. We'll review then in preparation for your test. You'll need to stay after school Thursday or Friday of next week, and that'll wrap up this unit right before spring break. Thanks, folks. That's all you math. Have a great day, and don't forget to like and subscribe.